Hello, Mario! In this video I'm going to just take a real broad brush approach to how you might measure power line clearance with a total station. There are a couple of options available depending on conditions and what have you. So let's get to a diagram. Whoa, it's a pretty busy looking diagram there, Murray, but nonetheless we'll have a look at it. So first of all here, the reasons that we look at power line clearances are for getting various bits of equipment and things under the power lines, or what sort of work we might want to do. Now there's plenty of videos around that'll give you a bit of an insight into what can happen with these, what sort of clearances you should be looking for and what have you. But it's up to the surveyor sometimes just to go out and measure the actual clearance. So I've got up here just a typical total station. Remember that the three things a total station can do is measure the horizontal angle, vertical angle, and the slope distance. In this case here, horizontal angles don't come into play. So the basic method is to set up somewhere just out in front of the line there, or at right angles to the line preferably, and to set a prism, or send out your chainmen with a prism and get them to stand directly under the line that you want to check the clearance for. So taking the prism and directly under the line, we can then take a shot to the prism, and in this case here I'm just working totally on clearance. There's a number of ways that we could do it, but what I'm doing is take a shot to the prism, so you'd measure the slope distance and the zenith angle, and from that you would be able to determine the difference in height between the prism and the instrument, and I've shown a horizontal line right through here in yellow, and the difference in height between the prism and the instrument would be just here, this little gap in here, which I haven't labelled. And then from that, using that and the height of the target, we can actually work out the height below the horizontal. So if we were, in this case that I've shown here, there would be a positive difference above the horizontal, so that would be plus, and then we'd subtract from that the target height, and that would give us the height below the horizontal, and it would come out as a negative. But that we need to perhaps just look at that without sign, so that would be the height below the horizontal. Now the next thing to do is then to take a shot to the power line. Now sometimes with the direct reading and reflex instruments that we have, we can actually take a reading to the power line, and it'll read a slope distance to the power line, and then we can from that, of course, we can work out again the height from the horizontal. Well, that'll just read us directly the height from the horizontal to the power line, or the height above the instrument line, which is exactly what we want. So we could just take that, and then we must add that to the height below to give us the clearance. However, in some cases, but where the weather is not on our side, particularly windy days, where the power line has got a fair bit of wobbling to and fro, up and down, it is sometimes quite difficult to get an accurate measurement to it. But hey, don't walk away, don't wait and come back again on a nice still day, although that would be a good thing to bear in mind when you're going out to do that. And if it was windy, to perhaps, if you could delay to a better weather, that would be great, but not absolutely necessary, because what we can do is just measure the zenith angle to the power line. Just measure the angle, and we can't get the distance, but we can use the horizontal distance that we determined to the to the prism. So using the horizontal distance that we determined to the prism, we can then, and the vertical angle, we can then calculate the height above. So and in some cases where we don't have a direct reading or reflex, not a reflectorless measuring system in our total station, that's an option that we can use. It's pretty important that we get these clearances right, and in fact it can be a matter of life or death, or life and death, or death. So what I suggest you do is possibly do a minimum of 2 measurements, two different and independent measurements, possibly even from different places, just to confirm that you've got it right and you've done all the possible checks. Now, I purposely haven't gone into the detail of the mathematics behind working these out at this point. I'm just looking at the methodology and how you might go about it, and we can look more closely at the actual mathematics involved with this, and some real measurements and what have you at a later date. So, there you go, measuring clearances under power lines.